Now, among the properties of logarithms, we have the basic inverse function relationship that says that y equals a to the x is the same thing as x equals log base a of y. Now remember, if we have, like, take the graph of y equals 2 to the x. Okay, imagine a table of y equals 2 to the x. You know that table. Write that table down. You should be able to write that down in seconds. And reverse the columns. If you reverse the columns, then you have the table of y equals log to the base 2 of x. And we've seen this a number of times now. We've seen the basic idea of inverse function, how we invert the table, and how that affects the graph. So you want to be aware of all that. Okay, bottom line is because of that, y equals a to the x means exactly the same thing as x equals log base a of y. If you reverse the table, the columns of this table, you get this function. Okay? Now, similarly, if y equals log base a of x, then x has to equal a to the y. Same idea. So, from the fact that the log function is inverse to the y equals a to the x function, you get both this and this. Now, another way that I wrote this down that becomes helpful, if your power function is aardvark equals a raised to the anthill, then the log to the base a of aardvark is equal to anthill. Now, whether that's helpful or not, I don't know. But it seemed to be helpful to several people in class. So we might refer to this. But all we actually need is this. Okay, well, we have y equals log of 5x plus 3. Okay, well, what we want to do is we want to express this as an exponential, in terms of an exponential function. Now, first thing we have to recognize is that the log of 5x plus 3, log means log base 10. So, y equals log base 10 of 5x plus 3. So I could write the 10 in there just to remind myself. And now we can see, okay, let's see. Y equals log base a of x. A is 10. Instead of x, we've got 5x plus 3. So we can write this as x, which would be the 5x plus 3 in this case, equals a raised to the y. Or if you wish, you have log base a of this aardvark here, so here's your aardvark, equals anthill. Okay, so here's aardvark, here's anthill. And what that means is that aardvark, which is 5x plus 3, is going to equal 10 raised to the anthill being y. Now, you just have to think through that. You just have to get used to reversing things in that nature using this rule. So if you like this rule, you can use this. Because this thing can be a little bit confusing because we've got an x here, but now x means 5x plus 3. How's that happen? That's why we call it aardvark and anthill. You call it anything you like. And you can read the way the book explains it. Okay, so in any case, y equals log 10 of 5x plus 3 is, I say inverse to, and that probably isn't a very good thing to say. It's the same as, it's not inverse to. So let me change my terminology here. It's the same as, okay, again, anthill equals log base 10 of aardvark. Okay. Sorry. Yeah. Yeah, right. Anthill equals log base 10 of aardvark. Okay, that's this. So that aardvark, your 5x plus 3, is 10 raised to the anthill, 10 raised to the y. Okay, so this equals this raised to this. Another way to look at it, but be sure you've got it straight. Okay, so that ends that example. Now we want to write y equals natural log of 3x minus 2 in exponential form. Okay, well, first of all, ln means what? It means log to the base e. So we write this as y equals log base e of 3x minus 2. Maybe we identify the aardvark and the anthill. The aardvark's the thing you take the log of. The anthill is what it's equal to. So you get aardvark, which would be in this case the 3x minus 2, equals a, which in this case is e, raised to the anthill, okay? Or this raised to this equals this, okay? E raised to y equals 3x minus 2. Okay, very similarly, if we have y equals log base 2, 5t plus 1, to put that in exponential form, it's going to be 5t plus 1 is equal to 2 raised to the y. Again, in terms of aardvarks and anthills, in terms of x's and y's, whichever way you are most comfortable looking at it, but be sure you understand that this is just an expression of the fact that the log base 2 is inverse to the 2 to the x function, okay? So, we have this. And again, okay, how do we write this one, which is in exponential notation, in logarithmic notation? Okay. Well, now we have aardvark equals a to the anthill, right? We have aardvark 10 raised to the anthill. Means the log of the aardvark, which is the log of y, is equal to the anthill. Okay? In other words, y equals 10 to this means log base 10 of this equals the exponent. And of course, then we could just write that. We don't have to write the base 10. We could just write it log y equals 4x minus 7. So, take the expression y equals 2 raised to the 3x plus 1. Well, that inverts to 3x plus 1 is log to this base of whatever this is. In this case, it's y. Now, suppose we have y equals e to the 5q minus 4. And we want to solve for q. Just giving you a little preview. How do we solve for q? Well, we can express this in terms of the log function. Log base e of y equals 5q minus 4. We turn this around to the logarithmic notation. And now we can, if we wish, solve this, okay? And this, we could write log base e as natural log, and then this becomes very easy to solve. Okay, we've got natural log of y equals 5q minus 4. Add 4 to both sides, we get log y, natural log of y plus 4 equals 5q. Divide by 5, and we've got q, which is natural log of y plus 4 over 5. Now, if you know the value of y, or you know what the expression is for y, and if you can evaluate that on your calculator, you have a solution for q. Now, we'll be solving exponential equations in our next series of classes. So, you're going to have, and exponential and logarithmic equations, we make use of how we change from one form to the other. Or alternatively, we make use of the inverse function property, taking the log of both sides or exponentiating both sides. It's all equivalent, and we got to get used to this. So hopefully you'll have done the homework on this section so that you're used to the way these things are rearranged, and you'll find then the solution of logarithmic and exponential equations to be fairly easy. They can get very tricky, but you know, to do basic ones, I hope you'll find it pretty straightforward.